evening. Today we have a question in two dimensions. So x and y. X can be given as a function of the time, t multiplied by 2t plus 1 to the power of 2, and y is also a function of time, 6 over the square root of 4t plus 3. We need to know the direction, the magnitude of the velocity of this particle, and the direction, which means the angle. So at time, when the time is half second, we take the first one. The first one is a function of time, but it does have the time is outside of the bracket and inside of the bracket, so I'm going to apply product law in it. So I will say product law in derivative. I take the derivative. This is the first, this is the second. So first times the derivative of the second, which is 2, times 2t plus 1 to the power of 1 multiplied by the derivative of inside of the bracket, which is 2, plus second, which is here, times the derivative of the first, which is 1. And when we multiply everything, so 2 times 2, that's a 4t, 2t plus 1, and that's the second one. At the time, when the time is 1 second, 1/2 second, or half second. So we substitute instead of each t, 1/2, 1/2, 1/2. After simplification, that's going to be 4 multiplied by 1/2, that's a 2, 2 times 1/2, 1 plus 1, and then this 1 plus 1, so the total is going to be 8 meters per second. That's the velocity with respect of x. So this is actually Vx. And then we take the velocity with y. So make things simple, since there is no variable on the top, there's only variable at the bottom, which is t. So I make this to the power of 1/2 and take it up. So that's going to be power of minus 1/2. Take the derivative, that's chain rule, only chain rule, I can say that. Chain rule. And I take the power down, and then power minus 1, which is negative 3 over 2, and then multiplied by the derivative of inside of the bracket. When we simplify this, 6 times 1/2 is 3, times 4 is 12, minus 12. This guy, I will put it in the bottom to make it power positive. When I substitute 1/2, I get the 1/2 times 4, that's going to be 2 plus 3 is 5. The 5 to the power of 3 over 2 at the bottom, and negative 12, so I got negative 1.07. That's meter per second, the velocity with respect of y-axis. Now the last thing, the direction is going to be given by tangent inverse of the opposite over adjacent. But I will take, the thing is, when I take tangent inverse of the opposite, which is, I will take it with the positive instead of taking the negative, as I am going to get the reference angle. And that's going to give me Vx, where the Vx is 8. That's going to give me exactly the value of 7.6 degrees. If I make a circle here, since my tangent is negative, so I am expecting that I will be in 2 quadrants. Quadrant number 1, tangent here is positive, tangent here is positive, so I am either here or I am here. And if I take the reference angle as it is, so this is the reference angle, which is, I said it is theta reference angle equal to 7.6 degrees, and theta here also with the reference angle, the same reference angle, which is, this is also theta reference angle, and that's going to give me also 7.6 degrees. So now I need to find two things. One of them, the rotation angle here, and the rotation angle here. That's it. So for quadrant number 2, I will say that quadrant number 2, theta rotation equals to 180 minus theta reference angle. Then we subtract that, so we get that. So that's going to be if I take 7 from 172.4, I believe, so that's a degree for the first one. For first quadrant number 4, when the tangent is also negative, and I have theta rotation in this quadrant is going to be given by 360 minus theta reference angle. So that's going to give me 360 in here, and minus 7.6. When I subtract that, I get 352.4 degrees. So this is the direction, either quadrant number 2 or quadrant number 4. Since we have the velocity of y is negative, and the velocity of x is positive, so we cannot take it in quadrant number 2, because in quadrant number 2 Vy is positive, so this answer can be cancelled. Just take this answer, and that's the direction of the velocity, and this is the velocities to amount. After the last thing we can do in here, maybe we can take the total velocity, which is going to be given by Pythagorean theorem, which is Vx squared plus Vy squared under the square root, and we apply that, so we have 8 squared plus 1.7 squared, and that's the magnitude. When we do that, we get the magnitude of the velocity meters per second, and this is the direction, and we said that the direction is going to be in fourth quadrant as the velocity in y-axis is negative, which is here, and it is not positive. That's the end of the questions for today. Thank you so much.